Hello, I'm Malolan Vasu from Lafayette College, and today I'm going to be talking about a vehicle counting model that works on traffic camera input footage and determines the number of vehicles going in each driving trajectory automatically without any human input on top of the video itself. Um, so, a big reason why we're doing this is just that traffic is a huge issue. There's a lot of lost money, there's a lot of lost time, and especially in developing countries, you're looking at a huge volume of vehicle flow, and traffic management can really help, you know, reduce some of the stress. So one example of, this so-called traffic management is, if you take a look at like an intersection like this one, it would really help to know where the most of the traffic is going, where most of the cars are flowing, and which lanes are they going in, and how many are going, right? This is really useful information to kind of determine signal timings, and you can kind of save some time there and optimize it. So yeah, so there are a lot of models that do this that count vehicles based on video camera footage, and some of them are presented at the AICD Challenge Workshop at CVPR. Most of them require you to annotate the video camera on top of the existing video footage. That is, you got to kind of say, okay, look at this region of interest, and you have to like draw the lines for the trajectories, and tell the model like you want the cars to be counted that are passing these trajectories. And the big issue with that is, especially in developing countries, that's just more overhead, that's just more labor, and this would not work on rotating cameras, or if the camera is continuously rotating. Uh, it's really, you got a lot more overhead involved. So our idea is to do away with all the human annotation. So simply given the video footage, we're going to try to determine the vehicle counts and the driving trajectories. The way we do this is kind of a two-step process. The first figures out the region of interest, right? So there's an assumption we make that the camera input video of the camera is positioned in a way that maximizes clarity of the region the user's interested in, right? So given that assumption, it does imply that if your object detector is more confident in an area, that means that's an area we're interested in. So with this assumption, with using the object detector confidence values, we can kind of determine the area within the camera frame where we're able to make good confident detections. Once we have that, um, we run an object tracking algorithm that tracks cars across frames. So we get a bunch of line segments for a car that flows across the region of interest. And once we have that, we can cluster tracks that are very similar to each other. So if they're starting at the same point and ending at the same point, those tracks are probably similar. So using some kind of math there, we can figure that out. Once we have all the tracks clustered based on similarity, we kind of average the track out and have one line representing the entire cluster. So that's going to be our movement of interest, or the representative trajectory, and for that lane, if you will. And after that, we just count the vehicles in that cluster, count the tracks in that cluster. That gives us our vehicle counts. So yeah, so this approach gives you the same results you would expect from the AICD challenge, and it works pretty well. We're looking at pretty decent mean absolute errors of 17%, great region of interest IOU. We have pretty good speeds, pretty good processing speeds. We're looking at 11 FPS on a Google Colab notebook. So if you just beef up the GPU even a little, you can get 10, 20, 30 FPS. You can get more than 30 FPS easily. That's real-time detection. Our object, our model does underperform when there are um, a lot of movements of interest, just because at those stages the complexity is much larger, and you're looking at a lot of similar tracks that may be misclassified. That's an area of improvement to focus on. Yeah, so in short, detector works pretty well. We're able to do it without any human input, just purely based on the video footage. It's really useful in developing countries where you have rotating cameras and you don't need an extra labor. And yeah, further work can focus on doing this real time. Right now, our model goes through the whole video and then counts it. Further work could do that in just one go. So yeah, that's pretty much it. Thank you for listening. We appreciate it. You can take a look at the code at GitHub, and yeah, have a good day.